Hey guys, welcome back to another video. Today we're going to be looking at this question from the IMC. It's a very interesting problem that we're going to try and work out. So we are given this semicircle and circle inscribed in it with point P as the center as shown. Okay, our goal is we're given PA is equal to PO. So this is equal to this. We're trying to find the ratio, okay? The ratio of the radius of the circle to the radius of the semicircle. So how do we approach doing this? This might seem hard at first, but it won't be when you actually understand how to do it. It is simply just some Pythagoras. The idea is you need to be able to realize and draw one important thing. And that thing is, I apologize if the sound might be a bit small. You might have not heard it well. Now it should be much better. I apologize. Now, so we are going to look at this problem. We're given as shown ratio of the thingies. Anyways, we extend this line. It's a straight line, clearly. Label this small r, label this big R. Let's use red instead. Okay? And this is, of course, a right angle. Now, this is also R. This is just big R minus small r, right? Now, this length is big R over 2. So we have this. I told you, it was very easy. Now, this is super simple. I'm not even going to cover this. We're just going to skip, and you result in which means R is equal to 3 big R over 8. So the ratio is 3 to 8, since R is not equal to 0. And that's first question done of the day. Wasn't too hard, was it? Now the second question is slightly more challenging. So the second question, what does the second question give us? It gives us a hexagon. And hexagons are notoriously hard questions. So let us construct. This is IMC question 24, by the way. So we are given this regular hexagon. Okay? And we are also given that the shaded area is a quarter of the area of the whole hexagon. Okay? Okay. So, what do we do? Well, what are we trying to figure out? We're trying to figure out if a person is here and walks this way, and another person is here and walks this way around, what is the ratio of the distances? It's a ratio again. Ratio of the longer one to the shorter one, obviously. Shorter one to the longest one, I mean. So how do we approach doing this problem? Now, first we're going to draw a line down here. And we're going to draw a line like this. This is 60 degrees, as is a regular hexagon, my bad. This is 90 degrees. This is 30 degrees. Let's label the side length x, okay? Yes, so what's the height? Now we know, okay, we know from our 30, 60, 90 triangles that this is half of x. So this is root 3 over 2x. So the whole thing is just root 3x. So now I have the height, right? Wait a minute. Just to review, if this is x, this is 2x, this is root 3x. In this case, x is 1/2 of x. So this will be, yeah, okay. I was just checking in case I did something wrong, and it's a good review. So, given root 3x now as the height, that is extremely helpful. We know, let's call this length, little length here, L, okay? The area of the whole hexagon, you should know this formula, is this. This is equal to 4 times, since it's 1/4, of root free XL. So root free XL plus the area of the two smaller triangles, which is root free X times the height, which is 1/2 X. So root free over 2, it should be root free over 2. Shouldn't it? Yeah, root free over 2x squared. Now, time to simplify. We get 4 root free XL plus 2 root free x squared. This is equal to 3 root free over 2x squared. Now we can immediately cancel out some x's. So this x is gone, this 2 is gone, and this 2 is gone. We can cancel out the radicals, the surds, like that. So what we're left with, and we can multiply by 2 on both sides. So this is now an 8, and this is now a 4. Wait, what? Guys, I feel like I just, I'm right. So 3x is equal to 8l plus 4x. Brilliant. Now what do we do? Okay, what do we do? Wait a minute. Guys, you might have noticed that I might have done something wrong in my calculation, because there is definitely something wrong in my calculation. Let's double check it, okay? Aha, now I realize my issue. When working out the area of the triangle, I forgot to divide by an extra 2. So this over here should be a 4. So therefore, this over here should be a 2 after being multiplied. Now this makes much more sense, okay? So now if you solve this, you get x is equal to 8l. Now let's work out how long each person walked. So the person who walked around this walked 2x plus 2l. So how much is that? That's 18l in total. Now the longer one walked 4x minus 2l, which is equal to 30l. So we have 18 to 30, which is equal to 3 to 5, and that is our answer. The ratio is 3 to 5. Now, this is a slightly longer video. We're going to do a last question, okay? Our last question is one very interesting. A gold coin is worth X% more. So a gold coin is worth X% more than a silver coin. So this is gold and this is silver. Then a silver coin is worth Y% less. Is worth Y% less than a gold coin. Both X and Y are positive integers. How many possible values for X are there? Okay. So, let's do this. We can set up equation. Let us see. We can set up something like a gold coin is worth, so we can have this X% more than a silver coin, and a silver coin is worth Y% less than a than a gold coin. So we can input S into here to give us 1 plus X over 100 times 1 minus Y over 100 times G. But there's already a G here, so they cancel and equals to 1. Now if we multiply by 100 squared, so we get 10,000. We can change this to 100 plus X, so everything is neat. Now this is just like a Diophantine equation, which we just have to solve, and it's already factorized. So what do we do? Now we can prime factorize this. Well, this is just 10 to the 4, so it's 2 to the 4 times 5 to the 4. Now using the formula to find the number of factors given factorization, we get 4 plus 1 times 4 plus 1 is equal to 25. Now, there are 25 factors, right? Now, since it's a square number, we know there are 12 factor pairs, right? With 100 as its lone because it's a square number. Now, if you think about it, there's going to be 12 over here and 12 over here, right? It's pretty obvious. Now, the thing about this is, how it can help us, is that if you observe, okay, x cannot be greater than 100, right? Otherwise, it wouldn't make sense, right? Because if x is greater than 100, then it doesn't make sense, because we can observe that x% more would basically be carried over, you know? So, like, say for example, if it were 100 plus 100 is 200, then it would be the 100 minus y, and this would be negative, right? So that would not be good. Or 0. So then it will not be equal. So therefore, there are indeed 12 possible values of x and y. And now we're looking for x, so it's 12 possible values. And that is our answer for this question. It's pretty interesting. I hope you guys enjoyed this video. It's a bit long, but please like, share, and subscribe. And I'll see you in the next mathematical or electrical video. See you guys in the next one. Goodbye.